As the world looks for ways to cut greenhouse gas emissions, researchers from Sandia National Laboratories have shown that a new 3D printed superalloy could help power plants generate more electricity while producing less carbon. Sandia scientists, collaborating with researchers at Amis National Laboratory, Iowa State University and Bruker Corp, used a 3D printer to create a high-performance metal alloy or superalloy with an unusual composition that makes it stronger and lighter than state-of-the-art materials currently used in gas turbine machinery. The findings could have broad impacts across the energy sector as well as the aerospace and automotive industries and hints at a new class of similar alloys waiting to be discovered. The researchers say that they are showing that this material can access previously unobtainable combinations of high strength, low weight and high temperature resiliency. The team published their findings in the journal Applied Materials today. About 80% of electricity in the US comes from fossil fuel or nuclear power plants, according to the US Energy Information Administration. Both types of facilities rely on heat to turn turbines that generate electricity. Power plant efficiency is limited by how hot metal turbine parts can get. If turbines can operate at higher temperatures, then more energy can be converted to electricity while reducing the amount of waste heat released to the environment. Sandia's experiments showed that the new superalloy, 42% aluminum, 25% titanium, 13% niobium, 8% zirconium, 8% molybdenum and 4% tantalum, was stronger at 800 degrees Celsius than many other high-performance alloys, including those currently used in turbine parts, and still stronger when it was brought back down to room temperature. This is therefore a win-win for more economical energy and for the environment. Energy is not the only industry that could benefit from the findings. Aerospace researchers seek out lightweight materials that stay strong in high heat. Additive manufacturing, also called 3D printing, is known as a versatile and energy-efficient manufacturing method. A common printing technique uses a high-power laser to flash smelt a material, usually a plastic or a metal. The printer then deposits that material in layers, building an object as the molten material rapidly cools and solidifies. But this new research demonstrates how the technology also can be repurposed as a fast, efficient way to craft new materials. Sandia team members used a 3D printer to quickly melt together powdered metals and then immediately print a sample of it. Sandia's creation also represents a fundamental shift in alloy development because no single metal makes up more than half the material. By comparison, steel is about 98% iron combined with carbon, among other elements. Moving forward, the team is interested in exploring whether advanced computer modeling techniques could help researchers discover more members of what could be a new class of high-performance additive manufacturing forward superalloys. These are extremely complex mixes. All these metals interact at a microscopic, even the atomic level, and it is those interactions that really determine how strong a metal is, how malleable it is, what its melting point will be, and so forth. There are challenges ahead. For one, it could be difficult to produce the new superalloy in large volumes without microscopic cracks, which is a general challenge in additive manufacturing. The materials that go into the alloy are expensive, so the alloy might not be appropriate in consumer goods, for which keeping costs down is a primary concern.